Okay, good afternoon. Okay, now we're going to see, we have 2 hours of practical session. So we're going to make use of this 2 hours to understand about gait and the muscle activation during each phases. Okay, there are key events in gait, right? What are the events? First, heel strike. Okay, where is the highest activation for tibialis anterior? Highest activation for VMO, vastus medialis, VLO. Is this mid stance the highest activation? We're going to look into. Okay, so what do you think we can see between left and right? What do you think we can see from EMG data? We collect data, right? So what can we see, and how can we make use of that data to do something about it? How are we going to make use of the data? Right dominant. How will we know is right dominant? Okay, which means if his right tibialis anterior, if his right tibialis anterior is more compared to his left tibialis anterior. So let's say right is more. What are we going to do after that? Okay, what does it mean first of all? What does it mean if his right tibialis anterior, the signal is higher than his left? Can we say weaker? We didn't check strength. So how can you use the word term weak? Remember, the words that we choose to describe movement should be correct. When you say weak, in terms of what? Okay, the signal is low left. What does it mean? What is it?
Muscle activation.
That is what we are talking. Muscle activation is less. What does it mean? When muscle activation is less, okay, I'll give you a scenario. When he's doing this, okay, 10. When he's doing this, 8. What does it mean? Yes, it's less activated. What does it mean? He's using more. Okay, what does it mean? Remember, we are trying to solve issues here. So now method we know gate processes, we know the gate phases involved. Okay, we know during which phase, which gate cycle, which muscle highly activated. So when you compare, you see that right is activating more than his left. So what do we do next? Okay, let's say the whole 3 muscle is higher than left. What does it mean? Assessment for injuries. What injuries? What does the signal tells you when it's giving you higher? Then go back and look at the technique. What technique is he? Because his ankle joint during that phase is less than his right compared to his left, causing that signal to be higher than his left. Is it because if yes, then is it because of his ankle stiffness or range of motion? Remember, we always go and search for why. Why until you solve it. The numbers is just a number. If you report it as a number without knowing why it happened, and solve it. Once you know, okay, his plantar flexion is more than his left, then you know the cause. If not, then go to the knee Is the knee angle, yes, is knee extension greater during that phase? To his left. So you must know the root cause of that. Someone said weak, and then go back and check his strength. Left and right. Ankle strength left, ankle strength right. Then you will get the whole picture. From there, now you can go and find the potential solutions. Potential solutions. Why we are trying to solve this? What will happen if we let him walk in that way? 10 and 8. Yes. The muscle will be using the right side, you'll be using the right muscle more. If you use one side more and one side less, you'll tend to have injury on one side before this leg because of overcompensation. Okay, look at his foot pronation, supination, which caused that to happen. Where will we check? Can we check that from side view? We need to check from posterior view. Set a camera here, set a camera there. That's why when we collect, just now we asked them to collect the data of video along with EMG. So that just with the signal, you can't understand much on what happened. Later, you cannot answer the question why if you don't have footages. Unless if this is a instrumented treadmill. If this is an instrumented treadmill, then maybe still I will collect video data. I will still collect full body because the data will not tell you why. The data will tell you what happened, but it won't tell you why it happened. Okay, that is the sequence of process of analysis when we are trying to look into the root cause of a problem. If you found out that both sides activated as usual, what will you do? You see all three muscles 10-10. What do we do with the data? What do we do next? What is that? How to improve. So how to improve, you compare with what? You want 10 to become 8 or you want 10 to become 12? No, we already do, we did maximum voluntary. So the 10 is based on maximum voluntary, the value. What do we do? So what is the sequence of proper activation when someone is walking? You know, there's we did this normative values, and during this phase it should be activated at this percentage, and then here, and then here. Go and check with normative values. Is it firing in that sequence according to the MVC standard? What is that, the normative value or not? Okay, if yes, what do we do with the data? If yes, it's firing according to the norm, everything within the norm, what do we do now? Come on. We talked about this, all these 4 days we talked about this. We are doing this for a reason. No, we are doing walking gait here. Okay, walking gait, we want to see if there is anything we need to add on to for him to have proper gait or not. If now everything is okay, so what do we do? Delete the file? Save it into his database. Save it into his database. Now you have a profile of a healthy athlete when he is healthy, when his gait is in good condition. After 6 months, unlucky, he got injured. Physio need to work. After 6 weeks, you test his gait again. And then now you compare with what? Don't look at normative value anymore. Don't look at from literature. Look at his norms. Take his norms out. Compare with his previous norms. Now you did strength data because you suspect it might have to do with strength. You check his range of motion. You check all this, all the parameters you are interested to look. You have it when he's healthy. Now when he's injured, you know where to work and how much to work. If it's 6, then you know, okay, I'm going to increase another 10 percentage. I need to do this technique modification. I need to strengthen this joint. I need to make this joint flexible. Because you're comparing, you know. Okay? I don't see anyone writing, storing here. Okay, understand, right? This is the process. When we do analysis, this is the process. We do to identify. Usually we don't simply do, but when we pre-season, when athletes come, we'll try to screen everyone when they are healthy before they go into high intensity season, so that we have something. If we have any issue, we'll work during the GPP phase. During the general phase, we'll try to solve. Just now I said, you know, whatever issue, 10%, 20%, GPP is the best time for your force to work on. If we don't have, we store it. And then kinematic analysis we do when running. All this general assessment. When we go to specific phase, we focus on strength and power. Strength and power during specific phase. General phase, walking gait, maximum strength, isometric tests, all these tests will have database when they're healthy, when they're strong. Because you know, usually the injury will happen when the loading is keep increasing. And then they get, if we don't want them to injure, usually some will get injured. When they come back, we have something to compare to in terms of strength, flexibility, because this strength, flexibility will affect the walking gait. That's why we are doing this walking assessment analysis, walking gait analysis. Okay, any question? Any question? No, unclear? Okay, what for volleyball, what general assessment will you do? For volleyball athlete, what general assessment will you do in a part of this walking gait? Smash for the spike, or the shoulder maximal strength. Remember I said you need to do the test, fit the test according to where they are now. They are just joining general phase. Yes, you can test low body power, upper body power. No, you cannot measure power at GPP. You can, but it will be meaningless. Because we will work on power and speed during SPP phase. You know training phases? We have phases in training. This is their starting, okay? 0 month, okay? This is 12 month. This is competition. Okay? So this is called as general preparation. This is called as specific. Did I draw this earlier? Day 1, day 2? Huh? This is, we call pre-com. Pre-com, last we call as tapering. Tapering, 2 weeks before. 2 weeks, it is not that long. Actually, it's happened. Okay, so there are few test batteries that you do during this general strength, walking gait, maximal strength, upper body, low body maximal strength, flexibility test. Okay, here, strength and power. Strength and how much is their explosive power and speed. Speed and power, not strength and power. Strength we have tested here. Maximal strength, speed and power. This is where, these are the block. SPP is the block for us to build their speed and power. We prepare the muscle and then we train their speed and power. Okay? And then here, pre-competition, mostly 80% will be, 70% will be tactical. Because they have prepared their body, their muscle to do practical. Technique will be from day one will be technique, but here emphasize on technique correction from previous competition. You know, we have data from previous competition, they did this mistake, unsuccessful rate is this. Where do we work? We work here. Technique correction, skill corrections, because this will be the biggest window for us. No competition. No competition during that time. Preparation, all rework, all that, everything will be there. Okay? My work will start here. After this. If there's no any technique correction here. Here. Okay, all the input that we have, we will work on that. The strength and weakness. Remember, we did strength and weakness. And then how to overcome that. All the tests to know the strength and weakness. We work there. Okay, clear? So one more thing. How many month out of 12, what are the percentage of breakdown? What would be the percentage of out of 12 months? How many months will there be GPP? How many months will there be SPP? Pre-com? Okay, this one, it goes back to coach itself. Generally, I prefer to have longer GPP. Because at the end of GPP, I will mix my SPP, half of my SPP there. Because once you have, because it's a foundation, you know. GPP, you build the foundation.
How many months will be GPP?
Sometimes 16 weeks. 16 weeks. It depends on sports actually. It depends on sports. 4 months we work on that. But usually in practical that will not happen. You know why? You know why in practical it will not happen? You will be preparing here and then they say there's a competition here. Can you say no? So you have to modify. You have to modify the design, training, everything. But you have solid 8 to 12 weeks, you will have no one will disturb you once they come back from off season. Usually January. But some sports which I'm working, this won't be January, yeah? This won't be January. I put 0 doesn't mean it's January, you know. This can be June. Okay, in my case, this is June. Okay, so if the competition is December, I cannot have 16 weeks. If my block one periodization is from June to December, I cannot have 16 weeks gone. 4 months, no. I have to shorten it. Yes. I have to reduce the microcycle which I'm working there.
Regular competitions every 3 months.
Not regular. Sometimes like we come back, next month there'll be another competition. Next month there'll be another competition. Some sports. That is why we have different of periodization plan. What the method I wrote here is linear periodization. Single peak. Linear periodization. One peak competition. But in practical, like I said, usually they use for Olympic cycle. On Olympic cycle, because you cannot suddenly make Olympic come in front. One Olympic cycle. But there'll be a World Championship in between, Asian Championship in between. We have Sea Championship, all the Southeast Asian country. One of the major, this December, is in Thailand this year. We are preparing towards that actually. And from there, next year, September, we have Asian Games in Japan. So our next peaking will be, first peak, December, second peak, September next year, in Nagoya, Japan. So we will prepare for that. And then following year, Olympic. 28, no, following year, 28, right? 28. 27, we have SEA Games. Malaysia will be hosting SEA Games. Okay, so tests And measurements, whatever we are doing, depends on which phase are we measuring. What are we measuring at which phase? It won't make sense if you go and do the gate analysis here. We need to know when is the right time to do the test. Unless he's injured and referred by the medical doctor. Then yes. Okay? Ready, sir? Okay, now we are looking at, okay, usually when you are doing, EMG, you have to integrate video. Without video, you won't know which activity happened during which phase. It's just a signal. Okay, so we have video separately and this EMG separately. Can we integrate video and this if you take separately? They say you record from your phone because there's no any tools to integrate and record together. You take separately. Can you integrate it? You can. There's a third-party tools to do that. Okay, third-party tool to do that. Because this is analog signal, your phone will give you digital signal. You need to find the converter. And then the capture rate, it will normalize to your phone. I think this is 2500, right? The sampling rate? 2540. 2000, around 2500. Okay, this, right, tibialis anterior. Where's left tibialis anterior? Can place side by side. Right tibialis and left tibialis side by side. Left VMO, right VMO side by side.
So the right VMO, left VMO, last top and bottom.
Okay, so I just switch the tibialis to this L, these two. Okay, as you can see, there's some noise, a lot of noise in the signal because we use the tape. We shouldn't tape because there'll be, like I said, artifact signals will be there. We shouldn't tape. There shouldn't be, no one shouldn't be touching it when you're running. So that's why when you place it somewhere, it should be placed where there's no contact will happen. That's why sometimes when you're trying to find this muscle, what adductor muscle is it? You'll find difficult because when you're running, there'll be contacting with left and right. Some muscles will be a bit challenging, Okay? Okay, this is right tibialis anterior. This is right. What is that? V or west?
That is right VLO,
RVLO. This is RVMO. This is right. All these three right, all these three left. Okay, but tibialis is this and left tibialis. If you synchronize the video and the signal, we can understand it better. Okay, if it's synchronized. Because when he's running and during this action, we can see the firing. Or during swinging phase, if his tibialis is still signaling, we know what is the cause. It shouldn't be firing when he's this movement. Okay? Okay, any question with data capturing just now? Data capturing. Anyone go and read about how to do MVC? No, sampling rate still same. We are talking about sampling rate here. Video also have sampling rate. This signal also, any analog signals, they'll have a sampling rate. That's why there's a device, not one device. There are multiple device actually, multiple device, third-party device, where the data will go into the device to convert the signal. I think it's called because before we have the current Norexon system. We have now current Norexon system. We can integrate video, we can integrate EMG, we can integrate IMU, we can integrate force treadmill, instrumented treadmill. For integrated together. You can see the video, you can see the kinematic, you put IMU everywhere, then the EMG and force sensor, ground reaction force. Norexon, Noraxon. Now it's we bought M4, now I don't know, M6, M5 or M6, I don't know, the latest one. Norexon USA. Norexon USA. Delsys is USA, right? Delsys USA. So Norexon, I'm not sure. Can you see Norexon from where? Anyone? Huh? USA also. So it will come with a treadmill. Norexon will come with a treadmill, and then two cameras, front and side. They'll come with the treadmill with force plate, and then IMU we have 12 sets of IMU where you just strap here, strap, and then here put it on the shoe, and then head one, and then you do calibration on the treadmill, and then you start recording. So all data will be in one page report. If there's anything out of the normative values, it will give you minus or whether plus knee flexion during this phase, or in negative, in positive. So we know where to work. Once you collect that, we know where to work. Okay?
This is the overlaid plot between left tibialis anterior and right tibialis anterior. There's the activation. You can see that while the left is activated, the blue is the right one. Right one is not activated. And overall, you can see that the left is more activated than the right one. This is the percentage actually. Since it's a calibrated, normalized graph.
Do you understand or not? What is percentage? You know the amplitude, what amplitude is this? This axis? This is just now when we do maximum, let's say we can go 100 maximum. But when he is running, he is only using 40. 40% of this. You see the percentage there?
ಒಂದು ನಿಮಿಷ ಅಲ್ದಿಲ್ಲ ಬರ್ತೆ ಹಿಂದೆ
Right? It's really less. This is not the actual data because because his NBC went lower than that. So the NBC we did is not accurate. If you do NBC the right way, because we just told you we can actually shouldn't use hand numbers. We should do something digital. We should put the things like the stuff. So all just when usually the highest activation of tibialis anterior.
So this is a 9 second. In this position, the video, this position you can see this pointer here, somewhere here. You can see during the 9 second, that is the right leg, right? That's the right leg.
He's walking or running?
He's running. I think it's a support phase where he's landing on the right leg. We can do these. We'll do the RVMO.
But you'll understand the concept, right? The concept is to understand. The concept is to understand left and right, and then the sequence of the muscle activation. Is it firing at the right sequence? This, this, that, this again. The sequence of activation. You will know that if you overlap all these signals. Overlap all the signals, you know the firing happens by sequence. Sometimes some muscles early activation, then we know okay, this maximal force generation is happening earlier. Okay, also we work on the zone, which you are easy because it's making left and right, the forward tail, which cause that activation to happen early before the expand. Okay, so this next PMO, right and left. Same, this right leg is, the right leg seems more normal for me actually. It's not overactivated. Something wrong with the left. The green color is left, right?
Green is left.
Green is left. Okay, it should look like this. This part should be left. Because right activated, left seems like below 5. The signal is not right.
Left VM, a lot of disturbance in left VM. Left VM, a lot of disturbance.
A lot of noise. A lot of noise here.
This part. This is the VLO, right and left.
This is VLO, right and left. Any questions here? Any question? Any question? Sure, you all don't have question.
So we can use this, put it on AI and it generates.
Screenshot, upload it. Let's ask the right question. We need to know what question to ask. What will you ask? Sure, no question. Why is it 350%? Why is it activated 350%? Anyone? So it should be, percentage should be compared with the maximum voluntary contraction. So its maximum when we do the test is 100. During its running, it's showing 300. Not that. Sorry. NPC is maximal voluntary contraction. There cannot be more than that. But there can be a reason that is not like that. There are said we are doing it static condition, isometric contraction. Okay, maybe they do some explosive, they can provide greater than that. That is not average. They're comparing with maximum. This percentage comparing with MPC, that calculated RMS. In clear, it shouldn't look like this. In clear, it shouldn't look like this. It should be 0, 100 here, and then every activity happens within this range. It cannot go to negative. Understand? Understand? No. If my maximum is 100, and then when I'm doing something, it's showing 300, is my maximum 100? No. No. Cannot be. So what do I do now? I do MVC again. Or I take the highest value from this as MVC. But we need 3 seconds, right? 3 seconds. 3 seconds, 3 sets.
3 seconds, 3 sets.
3 sets.
8 seconds gap.
Okay, this is just for if you are really doing analysis for EFG, you need to take all this into consideration. Go back and look into what are the right protocol to collect MVC for each muscle.
You can change the protocol in this.
Okay.
In settings, you can change the time, rest, automatic.
Okay, any question? If not, we go back to yesterday's work. Anything you're done? Yesterday's continuation of yesterday, practical. All done. Already have your dashboard until your dashboard or only your what is that? Tying pattern. Who already prepared dashboard? Dashboard means your results when you type will be showing all in the graph as a report. Okay, take out your laptop. Take out your laptop. Okay, can all of you all come back here, please? Okay, today, the objective for today is to look at all the unsuccessful videos and analyze why it's unsuccessful. As a performance analyst, we have all the successful and unsuccessful videos. And then we take all the unsuccessful videos, we create another template for unsuccessful. That is another layer. What could be the reason for it to be unsuccessful? What could be the reason for it to be unsuccessful? Throwing speed is not enough, not fast enough. The ball is not fast enough. Another, what else can it be? What is that? Judgment? No, no. Now I'm throwing. I'm talking about unsuccessful. I throw, I didn't hit him. So one reason can be because maybe because my position from where I attack is not a optimum position, the best position for my attack. It's very far. There's someone standing here, but I'm attacking that person. How will we know if you don't go and look back at unsuccessful techniques? We won't know. That is why today our objective will look into, yesterday I said go back and get it done. So that we can look into unsuccessful techniques from biomechanics point of view. Is it because your extension, what is that, shoulder extent, when you come to speed, we can break down again. What caused that speed to be less? Is it because you are trying to throw from you stand without using ground force? You need to go layer and layer and layer. And then you will get the reason. Remember, we always investigate why. We already know what happened. We already know 70% unsuccessful, 25% successful. Now 75%, our goal as a performance analyst or biomechanist is to convert into, reduce the unsuccessful rate to 70%. Start slow. Another 5% I want it to go next time when you are playing. What am I going to do? If without knowing, we won't know. So the next step after this is take all the unsuccessful videos and break it down into different KPI. Why it's not unsuccessful? Look from biomechanics point of view. Because he don't have enough strength. He don't have enough range of motion when he's releasing the ball. Whatever reason can be. Apply this similar technique to your own sports. In badminton, okay, take all the unforced error, forced error or unforced error. Take all unforced error, put in one video. Look from biomechanics point of view. Why every time I hit the net? Is it because my lunge is not long enough? I cannot reach. My racket hit is facing in this angle or this angle, or my elbow is inside. From biomechanics point of view, when you solve this, then your number will go up. We report to athletes and coaches, this is your success rate, this is your total number of net ball, this is total of overhead smash, backhand return, all this. But what are we doing to increase the number or reduce the error rate? That is why we act as a biomechanist. Look at the technique. Repair the technique, modify the technique to increase the number. Reassess again, next competition. Don't look at everything at once. Look at one, the most important thing. In this case, the most important thing is unsuccessful throw. Break down unsuccessful throw into what caused all the performance. Let's say you have four performance indicator. Okay, the range of motion when they throw, and then target zone, and then when they throw, how much they extend their body, use of hip when they throw, or only arm. And then most of the mistake comes from, okay, there's no hip rotation. And then work on that only to see if it improve the throwing speed. If throwing speed increase, the chances of scoring will increase. Then we are doing integrating performance analysis data with biomechanics data. Same goes to combat sport. Punch, kick, in which situation that happen? When I'm standing, or when I'm moving, or when I'm moving to the side, he hit me. Keep all the data, look at what caused that, then him to always give away points. And then is it because of his reaction, or is it because of his mentally he's not focused, psychological issue? Work on that specific issue, only one at a time. Maximum 2, that's it. Don't work for more. You can collect all this, but at the end you collect all this data to know where is the biggest performance gap. Once you identify the biggest performance gap, you know from there where to work on. Understand? Okay, now, any questions for today before we go for exam tomorrow? Yes, I will. I will send all the slides. Anything else? I will try to go and send by tonight. My Wi-Fi is not strong enough here, actually, because very large file. I have, you saw right, the video all there, the GIF files there. So I'll try to send from here because they have cable here. I'll try to send from here. Anyone have any Google Drive space? My Google Drive is full. Anyone? So that I can upload all into that Google file. You can share the link. Okay? So tomorrow, there'll be 50 questions. 50 questions. Everything will based on, mostly will based on practical. Mostly will based on practical. Mostly I would say half of it, another half of it theoretical. Okay? You know kinetics, you know kinematics. Okay, you know what should you do, EMG preparation, what are the important things, what is KPI, performance indicator, what are your use of force plate, what is motion analysis. Very simple. Motion analysis are used for what? To measure muscle performance. Can you use motion analysis to measure muscle activation? No. It's mostly for what? Motion analysis. Kinematics. Okay, kinematics. If you integrate with force plate, you can use joint forces acting at the joints. Okay, you can calculate force plate. We call inverse dynamic, but we are not going there. We are not covering that. Okay, there are inverse dynamic method to calculate joint force without force plate. Okay, so tomorrow the exam will be. So what time tomorrow's exams are? So what time they should be here? 10:30 exam. Huh? Okay. I will be here from 9:30. Can I come at 9:30? 1 hour for the, okay? I'll be here at 9:30. In case if we have any questions, we can just recap for 1 hour. 9:30 to 10:30, recap. 10:30 to 11:30, exam. And then?
We'll have a half an hour break. Then we'll meet for that.
12 o'clock, closing ceremony, right? Closing ceremony. Okay? Clear? Okay, thank you so much. I'll see you all tomorrow. Good luck for your exam tomorrow.